Did you know that someone at NetGuru spent entire hour thinking how to make our developers miserable, demotivated, unhappy at work? And please don't tell anyone outside of this room, but this person was me. We'll get to that later. I will uncover why I was thinking such horrible things. But first we start with a brain. And brain is this amazing governor you all have in your heads. And right now you're using your brain, you're listening to me as I'm saying, you're interpreting what I'm saying, you know the language, you know the words. And you have, I mean, you heard them before, that you know the meaning. So brain works like a pretty complex pattern matching machine. And that's the same when we solve problems, when we are solving problems. I mean, if we solved problems before, it's just easier to solve new problems because we knew problems. I mean, we knew these problems from the past. And now you may wonder why someone from delivery unit with a computer science degree is talking about the brain. Not by any means can I be considered neuroscientist or anything like that. I consider myself just a user of the brain, as you are, I believe, users of the brain too. And as a user, I always wanted to make sure that devices I'm working with works at their best. So I'm this a bit anxious guy who fixes all Airbnb clocks when they're out of sync. I just want to make them work properly. And I was working as a developer here on NetGuru. And as a developer, you've got all the tools to solve your problems. So you've got web frameworks, tasks to sleep well at night, all the design patterns that you can use with the software, not to mention Stack Overflow, and you can ask for everything. And 4 years ago, I stopped being full-time developer, so I became a manager, and I really missed all of that. I really missed tools to solve problems better, and that's how we discovered mental models. So mental models are these helpers, boosters, sometimes questions to ask yourself. The easiest comparison from software engineering, I believe, are design patterns, these from Gang of Four, for example. But you do not operate on the code, you operate on your thoughts. So that's the difference. And today, as a manager, I'm in the business of managing expectations. So to keep expectations clear, we aiming to just slightly improve your decision-making process and problem-solving skills. It won't be any revolution or anything like that. And we start our journey through mental models from an orange. And orange here represents Earth, our planet. And the problem we are solving is to create a map of Earth. And I did a pretty juicy, tasty experiment a few days ago to try create a map of Earth on a 2D surface. And as you can see, it's pretty difficult if you can imagine all these lands, how it looks like. It's pretty complicated. By the way, it still falls into a ball. I just missed Antarctica because I started from the south. And now let's do a quick thought experiment together. So think about Australia in your mind, about the picture of Australia on the map, and now think about United States, and now compare these two in your brain. And it looks like this. So actually Australia is 1% bigger than the continental part of the United States, these 48 states, this mainland United States. And it's a common misconception. People think Australia is much bigger because as long as you do not travel there and you don't experience these long flights, it's pretty, I mean, you still think it's much smaller. And that's because in school and for most of your life, you've seen this projection. It's called Mercator projection. And don't get me wrong, it's a perfectly good map, but it was made in the 17th century, and the key feature of this particular map was to make sure that all the trading routes for the ships are properly mapped. I mean, you as a ship navigator, you know where to sail, basically. And it does this job. So basically, it's a good map, but they just focus on this trading path, so it works. And now look at Antarctica, that's the South Pole of Earth. And now I will show you Antarctica on a different map when the main focus of this map was to properly map landmass and sizes. And Antarctica is there on the bottom, and now it is on the, like, difference is massive, because on the Mercator projection, as closest as you are to the pole, the more distorted landmass is. And that's because no one sailed there. I mean, it was ice, right? It was cold. There was no technology to sail there, no materials on the Antarctica, stuff like that. So it worked. And these are maps. I mean, maps has this feature. So when dealing with any kind of map, remember what's the main focus of this map and what's the relationship with the reality for a given map. And now we've got the first meta model today. And it's called Map is Not Territory. And it means that we are going much further than just speaking about the maps. So now we are speaking that abstraction is not abstracted. In other words, abstraction is not reality. And we are dealing with abstraction everywhere, basically. Like map is just an example, but I don't know. Burning Man's agenda is a map. Financial statement is a map. All these numbers you see, these are maps. And basically, while dealing with any map, we have to, as with dealing with map, while dealing with abstraction, you have to remember about these features. So remember what's the relationship with the reality of this given map, whether it's financial statement or Burning Man's agenda, for example. Interesting feature is that you can usually zoom in and zoom out on the maps. So as you see financial statement, you can usually zoom in to certain results and zoom out. That's features that all maps has. And we really need maps because reality is too complex to comprehend. That's why we need these shortcuts. We need these mental shortcuts. And from our engineering world, I see a lot of engineers there on in the room. Great example is documentation, because documentation is also a map that helps you navigate through the project. So when you are writing documentation, please be mindful about how it is created, what's the main focus of this documentation, what you are hiding from other developers, and make sure that it's there where, of course, it has to be, right? I mean, please write documentation. I don't know. Oh, maybe I'm standing too far. Maybe that's the case. And our brain, I will say a bit closer. Our brain, when dealing with new maps, is like you are letting the first thought in, and no one goes in. And we have to remember about that while dealing with maps too. Because if you're seeing the first map, like the first image of Australia of this Mercator projection, you might be unable to update it afterwards. Our brains are not so good at rethinking stuff. And now we are switching gears a little bit, and we are going to the forest. And forest is pretty complex system. And imagine you are a lumberjack and you see the forest, and probably as a lumberjack you just wonder how many of raw material of wood is there. If you are a biologist, you probably look at animals there, species that are living in the forest, how they cooperate with each other, stuff like that. And if you are an environmentalist, you're looking how much of an oxygen is being produced by the forest, how much CO2 is being absorbed. And all of these three groups looks at just a fraction. I mean, they're just scratching the surface of the forest as a whole ecosystem. And none of these sees the forest fully. And we have to remember about that while making decisions and while solving problems. And this mental model is called circle of competence. So we have to be aware what we know about stuff. And as with the example with the forest, we know our domain, but there are so many domains if we are solving a big problem and working with complex systems especially. And that's the circle of competence. So the center is what we know. The bigger circle is the things that we think we know. And the difference between two is our ego. And we have to really remember about that we've got pretty big ego. As you can see, the difference is pretty huge. So remember to ask to ask questions, and don't be afraid to ask questions. Because we you can solve problems much better if you ask someone from different domain just to look at different perspective from different people, as with example with the forest. And forest is a great example because there is one role in this, except this tree that looks at the forest fully, and we can say it's a forester or foresters who takes care of the forest. And forester is taking care of the forest. He or she owns the land and makes sure that it's preserved for the future generation. To be honest, I don't know literally how foresters are taking care of the forest. But they have all the main ideas from different domains. So as a forester, probably you got some basics of biology, like the main ideas from biology to take care of the forest, like basic ideas how to, for the lumberjack to just cut the wood, basic ideas from all these 4 groups. And when you are entering the new domain, it's pretty important effect to remember, and it's called Dunning-Kruger effect. So first, when you are starting to learning something from new domain, and just after a few weeks, you are reaching the peak of Mount Stupid, and you have really high confidence, but you really know nothing, like Jon Snow. And then you are into the valley of despair, but then it gets better. So don't worry about that. Be aware of this Dunning-Kruger effect. And in our engineering world, we face often with the question how to choose the best stack for the project. And it's a good example of circle of competence. Because, for example, as a Ruby on Rails developer, I would like to create every web app in Ruby, now in Java too, probably. But it's like that. If you're a Python developer, you want to pick Django and Flask. And we have to be aware that the real solution might be outside our circle of competence. It might be even outside of circle of competence of all NetGurus. So in order to make sure that we solve problem better and make decision better, we have to make sure where is our circle of competence, and the real solution might be elsewhere too. That's a great example of picking the stacks. And of course, picking not so suboptimal stack for our client might lead to unhappy clients. And as we are approaching topic of unhappiness, I will confess why I was thinking such horrible things about our developers at the beginning. So actually, we were solving the opposite problem. We were discussing how to make our developers happy, productive, and motivated. But we use mental model, and the mental model is called inversion. So instead of thinking how to make them happy, we started thinking how to make them unhappy. Sounds obvious, but inverting the problem helps us just name the things that we should avoid at any cost. So as following this example, we thought just remove knowledge sharing from the team, don't let them meet, stuff like that, don't let them do code reviews. And thanks to just pointing out all the things that you can do to make them unhappy, you know what you should avoid. And avoiding stupidity is the key feature of inversion, because it really shows you what stuff you should avoid to solve the problem. And avoiding stupidity is sometimes much better than seeking perfection, and we have to remember about that while making our decisions. And another example from engineering, I think when it comes to inverting stuff, engineers are pretty good, because if you're writing, you're already using inversion. Because when you are writing tests, for example, and looking for negative paths, you are trying to invert the problem or just cover the negative paths with tests. So that's an example of inversion, I think commonly used by our developers, especially while writing tests. And these 3 mental models that I showed you today, so map is not territory, circle of competence, and inversion, are part of category of general thinking concepts. And there are many of them, like few hundreds of mental models from different domains. And if you want to just find out more, I recommend you the work done by Farnham Street. You can learn more about mental models just Googling mental models, follow the blog post and podcast, highly recommended. And like I said, you can learn all of these mental models and like memorize all the examples, but without practice, you won't make your decision better and problem-solving skills better. So I encourage you to just do some decision log or some journal for your decisions, quick checklist to run through mental models while you're making especially important decisions. Of course, it doesn't have to be for every decision that you're making in life, but especially the most important ones. And there's one superpower I would like to leave you with today, and that's time. And like I said, you can know all the mental models and memorize them, but without taking time to make decisions, you won't get better, because to make good decisions, you need more time. So next time that when your client will ask you how much does it take to estimate, how much does it take to deliver a given feature, just pause politely and say that you will get back to him or her after a call. You don't have to say immediately. So time is the superpower to make decisions. And I really like Twitter. That's the only social media I consume, and I found it really valuable how big amount of knowledge can be just distilled and compressed into one tweet. So here is the tweet from 20 minutes of my talk today. Here it goes. Explore the maps you deal with and all the flaws. Know your circle of competence and ask for help when needed. Invert problems to start avoiding stupidity rather than seeking brilliance. And take time to make decisions. And that's it. Thank you very much.